All right, in this lesson we're going to study roots and radical expressions. Cube roots is up first. The cube root of a number is one of three equal factors of the number, just like the square root of a number is one of two equal factors of the number. For example, the cube root of 8 is 2 because 2 times 2 times 2 is 8. We see the three 2's there. A perfect cube is a number whose cube root is an integer. The number 8 is a perfect cube. The symbol, the little 3 outside of a root symbol, stands for the cube root of a number. The cube root of 8 is written as cube root of 8. Find the volume of a cube with edge length 3 centimeters. That's a problem we're going to try here. Let's see, we know the volume of any cube is equal to the side cubed. So we should be able to cube root both sides. Actually, no, we've got 3 centimeters, so 3 cubed. The volume would just be 3 times 3 times 3, or 27 cubic centimeters. Find the edge length of a cube with a volume of 8. Well, now we know the volume and we're looking for the edge length. So again, 8 is the volume equals s cubed. If we cube root both sides, s would equal the cube root of 8, which is 2. Or 2 centimeters. The volume of a cube is 27 cubic inches. Find the length of the edge of the cube. Well, here's a diagram. We know that volume equals 27 inches cubed. Volume equals s cubed. If we cube root both sides, we need to find a number that times itself 3 times is 27. Well, that's 3. 3 times 3 times 3 is 27. So the length of the edge of that cube is 3 inches. Perfect squares. You're probably familiar with most of these perfect squares. We need to become familiar with the perfect cubes. The first perfect cubes are 1, 2, 3, 4, and 5, or if we cube those, we get 1. We cube 2, we get 8. We cube 3, we get 27. Cube 4, we get 64. And cube 5, we get 125. So we need to recognize 1, 8, 27, 64, and 125 as perfect cubes. The same way we recognize 1, 4, 9, 16, 25, 36, and so on as perfect squares. If we can do that, then cubes are going to be simple for us. So 1, 8, 27, 64, and 125. Isn't it kind of interesting that 64 is both a perfect square and a perfect cube? Does that make you wonder how many numbers are like that? All right, let's try some problems. Find all real square roots of 0.0064. Let's see, square roots, they could be positive or negative. Find all real square roots. Let's see, that's got to be B, 0.08 and negative 0.08. Let's try another one. Find all real cube roots of 0.000001. Well, it's a cube root, therefore the answer, this is positive, so the answer is only positive. So that gets rid of A and B. This is too big. If I cube that, I'm going to have way too many decimal places. It's got to be C. Let's try another. Simplify the radical expression. This is something we need to spend some time with here. So I recognize root 150. I see a perfect square that goes into 150. That would be 25. I know that 25 times 6 is the same as 150. So I can simplify this down a bit. The square root of 25 is 5, and the square root of 6 is 6. So the simplified radical would be 5 root 6. We can check our answer with theirs here. 5 root 6. Same thing we just got. Let's try another one of these. Root 144. Well, we know that one. That one's 12. Let's try another one. Root 50. Again, I see a perfect square factor of 25. So that would be root 25 times root 2. 25 times 2 is 50. We know the square root of 25 is 5. The square root of 2 doesn't simplify, so 5 root 2. Check our answer with theirs. 5 root 2. And let's go on to the next type here. It doesn't always work out to be 25 here. We've just gotten kind of lucky a couple times. Here we go. This is 5 root, or square root of 5 over 36. Let's break this division apart. Let's make it the square root of 5 over the square root of 36. It makes it much easier. Square root of 5 doesn't simplify, doesn't have any perfect square factors other than 1. Just leave it alone, root 5. But root 36 is just 6. So we're going to stop at root 5 over 6. That should match their answer. And it does. Alright. Let's try this last type. Cube roots. Cube root 120 over cube root 3. Let's see. That's the same thing as, we can go the other direction here with the root, 120 over 3. 120 divided by 3 is what, 40? So cube root 40. We've got to find a perfect cube that goes into 40, not 48, 40. We remember those are 1, 8, 27, 64, and 125. Well, I know 8 goes in there, so let's factor in 8. Cube root 8 times cube root 5. 8's the second perfect cube, so the cube root of 8 is 2. So we should get 2 cube root 5. Let's check our answer with theirs. Same thing. All right, good job. And that's our learning target for this lesson. I'll see you in class.